In this video I want to show you how to write and balance chemical equations. So what is an equation? An equation, it can be mathematical or chemical equation, must have the left and right sides equal. So we shouldn't call an expression an equation until it is balanced. So for any mathematical or chemical equation, we need to balance the right hand side and left hand side. Chemical equation. An equation can be balanced only by adjusting the coefficient of formula. So what are the coefficients? We will see that later on. So balanced chemical equation. In a balanced equation, the total number of atoms of each element present is the same on both sides of the equations. For example, here we have 2NO plus O2. It's going to give us 2NO2. So if we count the number of atoms of nitrogen and oxygen in left hand side and right hand side, they must be equal. So here we have 2 nitrogen atoms. On the right hand side we have 2 nitrogen atoms. On the left hand side we have 2 oxygen plus 2 oxygen, 4. And on the right hand side we have 4. And you can see here too, we have 2NO plus O2 is going to give us 2NO2. So we can say this equation is balanced. So what are stoichiometric coefficients? The coefficients required to balance a chemical equation are called stoichiometric coefficients. These coefficients are essential in relating the amounts of reactants used and products formed in the chemical reactions. So whatever you see in the left hand side of any equation, we call it a reactant, and on the right hand side we call it a product. So it means that during the reaction, reactants are consuming and the products are producing or they are forming. So on one hand we have consumption or usage, on the other hand, on the right hand side we have production or formation. So let's see how to balance an chemical equation. So here we have balancing by inspection. The method of equation balancing is called balancing by inspection. Balancing by inspection means to adjust a stoichiometric coefficient by trial and error until a balanced condition is found. So here's the procedure. If an element occurs in only one compound on each side of the equation, try balancing this element first. Second, when one of the reactants or products exists as the free element, balance this element last. 3. In some reactions, certain groups of atoms, for example, polyatomic ions, remain unchanged. In such cases, balance these groups as a unit. 4. It is permissible to use fractional as well as integral numbers as coefficients. At times, an equation can be balanced mostly easily by using one or more fractional coefficients, and then, if desired, clearing the fraction by multiplying all coefficients by a common or proper multiplier. For example, here we have this chemical equation, we want to balance it. We have NH3, which is ammonia, plus O2. It's going to give us N2 plus H2O. So we need to balance this chemical equation. So what we need to first, since there is only one nitrogen atom in NH3 on the left and 2 nitrogen atoms in N2 on the right, the coefficient must be added in front of NH3. So we add these 2 here. So now you can see the number of atoms of nitrogen are balanced. 2 here, 2 here. Next, since there are 6 H atoms or hydrogen atoms in 2 NH3 now, on the left hand side of the equation just written, and only 2 of them on the right hand side. So here we have 6. 2 times NH3, we have 6 here, and on the right hand side we have only 2. So we need to multiply this by 3. So the coefficient, or the stoichiometric coefficient for water, is going to be 3. So now you can see both nitrogen and hydrogen are balanced. 2 nitrogen, 2 nitrogen, 6 hydrogen, 6 hydrogen. Then what remains here, we have oxygen. We need to balance oxygen as well. So let's see, we have 2 oxygen on the left hand side and we have 3 oxygen on the right hand side. So there are now 2 oxygen atoms on the left hand side and 3 oxygen atoms on the right hand side. 3 oxygen atoms can be shown on the left by placing the coefficient 3 over 2 in front of O2, or 1.5. Okay, so when we place it here, the equation will be balanced. In order to get rid of this fractional unit, we need to multiply all these stoichiometric coefficients by a proper number, which is going to be 2. If we multiply all of them by 2, we get rid of this fractional number. So we need to multiply all the equations by 2 to produce a balanced equation in which all the coefficients are integers. So we have 4NH3, 3O2, 2N2 plus 6H2O. So number of nitrogen here we have 4 on the right hand side. Hydrogen we have 12, here we have 12. Oxygen we have 6, and here we have 6. Next example, CO2O3 plus C is going to give us CO plus CO2. So first of all, we need to balance atoms that occur in more complex substances first. Always balance atoms in compounds before atoms in pure elements. So it means that here we have 3 oxygen, and on the right hand side we have 2 oxygen. So to balance oxygen, we put 2 before CO2O3 and a 3 before CO2. So we get 2 CO2O3 plus C. On the right hand side we have CO plus 3 CO2. So number of oxygen, we have 6 here and we have 6 here too. So it's balanced in terms of oxygen. Now we have 2 other elements, CO and carbon. So balance atoms that occur as free elements on either side of the equation last. Always balance free elements by adjusting the coefficient on the free element. For example, here, because we have free elements here, we need to balance CO. On the left hand side we have 4 atoms, on the right hand side we have 1 atom of cobalt. So to balance it, we need to put 4 as a coefficient here. So we have 2 CO2O3 plus C. It gives us 4 CO plus 3 CO2. So now, as you see here, we have 4 CO and 4 CO on left and right side of the equation. So then we need to balance C. So far we have this equation. We have 1 carbon atom on the left hand side, and we have 3 carbon atom on the right hand side. So we don't need to just put 3 as a coefficient for carbon to balance the whole equation. So we have 2 CO2O3 plus C, 3C is going to give us 4 CO plus 3 CO2. So we have 4 cobalts, 6 oxygen, 6 oxygen, 3 carbon, and 3 carbon. On the left and right, you can see the completed one. We have 4 atoms, 4 atoms, 6 atoms, 6 atoms, 3 atoms, 3 atoms. Next example. Balance the following reaction. We have C4H10, which is butane, plus O2 is going to give us CO2 plus H2O. In this case, we start with C, carbon. On the left hand side, we have 4 carbons. On the right hand side we have 1 carbon. So 4 and 1, we need to place 4 in front of CO2. So we have C4H10 plus O2 is going to give us 4 CO2 plus H2O. Now it is balanced in terms of number of carbon atoms. Then we need to balance H. We have 10 hydrogens here and we have 2 hydrogens on the right hand side. So what we need to do, we need to place 5 as a coefficient for water. So we have 10 here, we have 10 here on the right hand side. So what is remaining is oxygen. We need to balance O as well. Here we have 5, here we have 8, so 13. On the other hand, we have 2. So if we put 13 over 2, we can balance this equation. And after that, we can multiply all of them by 2 in case we need it. So if the balanced equation contains coefficient fractions, clear these by multiplying the entire equation by the denominator of the fraction. So finally we get 2C4H10 plus 13O2 gives us 8CO2 plus 10H2O. And this will be the final balanced equation. So we have 8 carbon atoms on the left hand side, 8 carbon atoms on the right hand side. 20 hydrogen atoms on the left hand side, 20 hydrogen atoms on the right hand side here. And 26 oxygen atoms on the left hand side, as you see here, and 26 oxygen atoms on the right hand side. We have 10 here and we have 16 here. 16 plus 10 is going to give us 26.